Uh, Good morning, everybody. Shall we start or shall we wait for some more people to join in? I think we have how many? 27 people, including myself. So, uh, okay. So, I think, shall we start or should I wait? Maybe I'll wait for a few more minutes. Okay. The people are there. So, we have 30 participants now. I'll wait for 1 or 2 more minutes, then we will start. Okay. Good morning, everybody. I think we can't wait anymore. Let us start. So let me just repeat what I was doing in my last class little bit. We were discussing functions, but before I move ahead, let somebody say that my screen is proper. You are able to see my screen. You can see me and you can hear me. Somebody may just tell me that everything is good. Then I'll move ahead. Anyone?
Yes, sir. You are
Yes, sir.
very much audible and visible.
Excellent. So, if you remember, guys, last time we had done this. We had done this. Let me recall. If let me repeat. In Python, whenever you want to write a function, you have to use the keyword def. The def is a keyword. As I explained, this is the keyword. This means this is giving a signal to the Python interpreter that whatever follows will be a function. So this def keyword in Python is understood by the compiler to mean that, and this myfunc is the name of the function. Myfunc is the name of the function. Name of the function. Name of the function. Right? And this arg1, arg2, and arg3. This arg1, arg2, and arg3. These are the three arguments which I have given to the function. There are three arguments. And this 1, 2, and 3. These are the three default values for these three arguments. That means arg1 will have a default value of 1, arg2 will have a default value of 2, and arg3 will have a default value of 3. This ends the function definition, followed by a colon. There has to be colon. If you don't put the colon, the interpreter will throw an error. Then you have to give 4 white spaces here. These are 4 white spaces. Then you have to give whatever you want to. Whatever this, I've given a print, and this I put. Let me just clear the screen a bit. And so in the print, this is the print statement. This is simply a string. This is enclosed in single quotes. So it will be printed as it is. Whatever is inside will be printed, comma, and then arg1. This is the variable. So whatever is the value of arg1 will be printed here. Then arg2, then value of arg2, then arg3, another string. So there are 3 strings, 1 string, 2 strings, and there are 3 strings which will be printed. And there are 3 variables, 1 variable, 2 variable, and 3 variables. So 3 strings and 3 variables will be printed. Let us run this function. And as you can see, so let me just, for the purpose of repetition, this string gets printed as it is over here. And this arg1 gets printed over here. This arg2 string gets printed over here. The value of this gets printed over here. This string gets printed over here, and the value of this string gets printed over here. So there are 1, 2, 3, 4, 5, 6 items which are printed. 3 of them are the 3 strings, arg1 arrow, arg2 arrow, arg3 arrow, and 3 of them are the variables arg1, arg2, and arg3. So sir, this is this.
Sir, I have a query.
Yes, please.
So why we are not calling here argument 1, 2, 3 as the parameters?
Yeah, they should be. Yeah, okay. You can call them parameters also, because you see, there's a function. I am a bit. I'm not sure. See, the arguments in the function definition. You see, it's very important that beginners don't understand the difference between function definition and function call. So whenever you are writing the function, it is a definition of the function. In the function definition, they are called arguments. In the function call, they are called parameters, as I understand. But it could be other reverse also. I'm not sure. You need to check it up. In one place, it is called arguments. In other place, it's called parameters. To the best of my knowledge, in the definition, they are called arguments. In the call, they are called parameters. I hope that answers your question. Yeah.
Okay.
No, sir. You are vice versa. It's vice versa.
It's
in
vice
function
versa.
Definition, it's parameters. Function call, it's argument.
Okay, fine. So function call is arguments. Maybe I'm a bit this thing. So in function call, it is arguments. In function definition, it is parameters. Right. So okay. So now, but the point I'm trying to make here is something different. Now, see, if I call this function, now let me just make a change to it. Let us put say, let's put here x. Now, can someone tell me what is going to happen now?
R1, so argument 1 will give the value of x, And argument 2 and 3 will remain the same.
Yeah, so let us run. So that is right. So now argument is giving the value of x, because this argument has, because this x has gone into this, has gone over here, it has got printed over here as x. And argument 2 and 3 are continuing to be 3. Okay, now I have a question for all of you. Now suppose I want that argument 3 should be y. Argument 1 should be 1 only, argument 2 should be 2 only, and argument 3 should be y. Then how do I do it? Can
So
I
we
do
have-
like this? Can I? Yeah.
So we have to rearrange the parameters. We have to write
if I-
argument 3
okay.
first.
No, no. First you, okay, don't jump it. Suppose I write like this. Can I put y into argument 3? No. Why? Right? Because this one, so one way of doing it would be, I put 1, 2, 3, right? Now let me run it. So now it's good. So now what has happened is that this 1 has gone over here, this 2 has gone over here, and this y has gone to argument 3. So if I want to give the, if I want the default values of 1 and 2 to continue to remain the same, but I only want to change the value of argument 3, then in the normal call, I have to give the 1 and the 2 before I give the y. Otherwise, if I don't give the 1 and the 2, then this y will go into argument 1. I hope that makes sense. Now, to bypass this problem, Python has created a system whereby you can write arg3 equal to y, right? So now let us run this. So if, as you can see, now the interpreter is very smart. It understands that only argument 3 is y. So it will give the y over here, and this y gets printed an argument 3 in this statement. Argument 3 becomes y, and it prints a y over here. So this system of passing the values to the function in a function call. Remember this. Let me just write it again. Let me just, because I need to really differentiate. This is the function definition, and this is the function call. You need to really understand the difference. This is a function call. This is the definition of the function. So in the function call, you can specify the values of the arguments. This is called key value pair. So you are passing the arguments in the form of a key and a value. This is the key, this is the value. So you're passing the arguments in the form of key value pair. So the advantage of this system is that you can pass the values and the keys in any order, and that is the advantage. Now suppose I wanted to I wanted to write argument, then I write R1 equal to say x, and I write R2 equal to z. So what I have done, just let me run this. As you can see, so what I have done, the order in which I'm passing this is my function. See, note, remember, this is my function call. In my function call, my arguments are not, these are my arguments. These are not in the same order as the arguments in the function definition. So that is why I have to tell the interpreter that, look, interpreter, I want argument 3 to come first, argument 1 to come next, and argument 2 to, I will do like this. Then the interpreter says, okay, you can do it, but tell me which is what? Tell me that y is not to go into argument 1. So you tell this to the interpreter by saying argument 3 equal to y, arg1 equal to x, and arg2 equal to z. So this is the advantage of using this key value pairs in the function call. So let me again repeat, in the just let me write it again. In the function definition, you can give the default values. And in the function call, you can use what is called the key value pair. So I hope this concept is clear. So this is very important in some of the advanced, like when we cover things like pandas and all. Many of the functions in pandas, they may have 20, 30 arguments. You want to change the value of only one of those arguments, which may be at position 25. So if you don't have this kind of a system, you have to give the values of all the 24 arguments before you can give the value of the 25th argument. To bypass that system, to make programming easier for the normal person, for the programmer, the Python interpreter has this system called key value pair, whereby you can give the values to any of the arguments in any order. Of course, if you do not give values to those arguments which do not have default values, then it will throw an error. So I hope this is clear. We can move ahead. So is it clear to everybody? Can we move ahead? Anyone with questions on this?
Yes, sir.
Okay. Right. So let us move ahead. Because we have quite a lot to cover. So, okay. So I think we will move to the next topic, which is just one sec. Just one sec. Just give me a second. Yeah. So we have covered this. I will not go into this keyword. This keyword argument, just I will repeat. This is given in the HTML, which is there on my GitHub page. Okay, just to okay. See, in some programming language, you can use the syntax F A comma B comma C. Then the interpreter will understand that this two commas के बीच में जो खाली space है, this stands for the second argument, right? But you can't do this in Python. In Python, you have to give the keyword argument, key value pair as your listing, right? I hope that is clear. Okay. This is using both default values and keyword arguments together. You can use them together. And as I'm just repeating it again and again, because this is something which many beginners miss out. Default values are always given in the function definition. And the keyword argument pairs are always given in the function call. So when you're calling the function, you can give keyword arguments. If you're writing the function, you will be using default values. And you see, if you are into unless you're writing your own libraries, your own programs, most of the time you will be using the functions and which are available in the libraries built by others, libraries like pandas and all that. So there you need to understand the header of the function. That means if pandas has some function, say get something, and it has got 20 variables, then you need to know which are those 20 variables and what kind of values they can take. Some of them can take some can take numbers, some can take floats, some can take ints, some can take bool, some can take strings, like that. So you need to understand this. Let's move ahead. Okay. The next important concept. Using variable number of arguments in a function call by using the syntax asterisk in the function definition. You read the statement carefully. Using the variable number of arguments in a function call by using the syntax of asterisk in the function definition. I will give an example. Let us write a small script. Sitting here, right? Yeah. Now just bear with me. I will just change this whole thing. Suppose I have a function, say a comma b, and I write print A plus B. And I call this fx with say 3, 4. Let me run this. Let me write. So I get let me just show this. I've written a simple function with the keyword def. The name of the function is fx. It takes two inputs A and B, and it prints the output by adding the two as 7. So simple function, not a problem. But suppose that they give you a problem. Okay, you write a function which can take variable numbers of inputs. That means suppose I give you 3 numbers to add, then you should be able to add 3 numbers. If I give you 4, this function should be able to take variable numbers of inputs. Then how do you do it? So the system for that is, I will just show you. There's a concept called star or asterisk arg, and then let me not write print. Let me just first write print type arg, or let me write print arg. Let us just see what this function does. Okay, let us call this function fx with one variable. Let's 3. Let's do it. So what is, just see this. So what is happening here is that there is a function definition in which I have used in the argument I've used star arg, right? And I've called this function fx with one variable 3, and I get an output of 3, this thing, right? So this shows that it's a let me just show you what is the type of arg. Let me see. Let me show you. Print type tuple. Just see. So that means this arg is of the type tuple or tuple, whatever you call it, tuple or tuple. That is why it has round bracket, a 3, and a closing bracket, right? Okay. This comma after the 3 is important. Otherwise, it will not be a tuple. You need to have this comma, right? So what has happened over here is that the 3 has gone into the arg, and arg is a tuple. It contains one item, 3. Now suppose I put a 3 and a 4. Let us run this now. So you can see. That means now earlier I called this function fx with one argument fx3. Now I am calling the same function fx with 2 arguments 3, 4. So my interpreter, what it is doing, it is taking all these arguments and it is putting it into a tuple called arg. You can use anything. You can use fox here. You can use fox.
So, but why, unlike in the previous instance, it's when we passed single parameter, it came out with 3 comma. Now, when you say 2 parameters, it did not come out with 3 comma 4 comma.
Yes, because good question. Because if you write simply 3, if you write just let me show. If you write simply, just one second. If you write simply 3 like this, then how does it could be 3 within brackets? It would be number 3. Let me just show you. Suppose I write z is equal to 3, right? Print z. Let me print type z. Oh, it's giving an error. Sorry, sir. Let me remove this. Let me put this in. I've commented out the entire thing by putting double quote. Let me run this now. See, now just see. If I don't put the comma in front of the 3, then 3 will be treated like an int. Clear? I hope that answers the question, whoever. But if I had a 3, 4 in brackets, then the Python interpreter is able to understand that this cannot be an integer. This has to be a tuple. But if I put a 3 without a comma, then the Python interpreter will think this is an integer. But if I put a 3 with a comma like this, then the Python interpreter knows it's a tuple. So therefore, to remove the confusion between this and this will be treated like an integer. This will be treated like a tuple. I hope that answers your question.
No, I thought the moment you put star, the output is always a tuple. So therefore, I was hoping that anything which is going as a single output or a multiple output would go with the last thing as comma, because it doesn't know what is the end. So therefore, there is a comma. I thought it that way.
No, I have not been able to follow your question, but let me repeat it in case you have not understood. What I'm saying is that if you write x equal to 3, and if you write y is equal to 3 comma, so here the interpreter will treat 3 as an int. Here the interpreter will treat this whole thing as a tuple. That's the thing, right? So if you have a thing, in fact, you can even write, if you write, let me show you again. If you write, let me put another, let me put w is equal to 5 comma. Let me put type print. We are getting sidelined from the main topic, but I think I need to understand you. So what should be the answer now? Anyone? Let's run it.
It's tuple.
Yeah. So see, the interpreter now understands that if you put a comma in front of the number without even the brackets, then the interpreter will treat it like a tuple. But if you put the number inside the bracket without a comma, it will be treated like an int. But if you put a comma over here, it will be treated like a tuple.
That's a new insight.
This answers the
Thank
question,
you.
but this is not. Sorry.
Yeah, okay. That's a new insight. Thank you.
Okay, fine. So I was saying that you can print some, you can call it fox also. So if you write print fox over here, that's good. If you write print type of fox also, you're good. Let us run this. Okay, no, but I have to remove this. Let me remove these. Whenever you want to, one good way of programming is that if there's a piece of code which is creating problems, enclose them in triple quotes. So let's run this. So therefore, now fox is a tuple. But you see, Python is a language of conventions, and because it is a loosely typed language, unlike Java and C++, where you can know the type of the variable, because every time a variable is created in a language like Java, C++, they will always write int. They will always write in C++. They will always write int fox or int x. So you know that x is an int, but in Python you write x is equal to something. So you don't know what is contained inside x. Therefore, in Python, it is very important to follow the naming conventions. I have not covered naming conventions, but I will just list some of them out. I'm digressing from the main topic, but let me just do it. Some of the common naming conventions are snake case, camel case, Pascal case, and I think other is capital case. I think this is what it is called. So in snake case, you write, suppose I write A_B. This is snake case. But if I write A, B, C as the name of the variable, suppose I write my int. So this variable, I've used a capital in between. It's like a hump of a camel. So that's a camel case. But the first letter is small and the middle letter is capital. But if I write my int, then what is happening? The first capital letter is also capital, the middle is also, this is called Pascal case. But if I write my int, this is called capital case. So in names of functions, you should try to use snake case, or you may use camel case, but never use capital case. Never use. Don't try to use, because if you write, you can write. There's no problem, but your code then will not be understood by others. In my book, there's a small script. There's a small exercise how to convert one case into another case, but that is a area of regular expressions which Balaji has told me we have to cover. We will see whether we can do it. Okay, anyway, we got distracted. So let us come back. So, I hope this single asterisk is clear that, we can do it. Let me just take it forward. Okay, I want to save time. So I've written this function here. I will just copy it. By the way, this is chapter 5 of my book, which is there. It's in HTML. This is HTML chapter 5 function. Let me just show it. Functions, more advanced concepts. So this HTML is available on my GitHub page, as I've already explained. Wait. Yeah, here. So you can see on my GitHub page, on that book chapters. Let me just show this. You don't have to buy my book at all. You can just book chapters HTML. Here, chapter 5 is there. So just just down below, this is chapter 5 is here. Here is chapter 5. So if I click this if I click this, it will be here. Or I can just otherwise what I can do is I can go here, and this chapter 5 is here. So I can just open it like this, and it will open that same chapter 5. This chapter 5 is there. So this is what we are doing, right? We had covered this. We were keyword arguments. We have covered this. Okay. So we were doing this part. So I was doing this def with this thing. So this is a function I have written, which is adding up the variable numbers given to it, right? Let us copy this function and run it. Let's copy it. So if you download the HTML from my GitHub page, then you won't have to write the entire code on your own. Even though writing code on your own is always a good idea, but to save time, those who are short of time, let me run this. So let me just show this code to you once so that it is clear. So this is the function definition, and there are two calls, one call and second call. In the first call, I have printed the value of f, giving it 4 variables, 1, 2, 3, 4. In the second, I have given it with 2 variables, 1 and 2 only. Two not variables, 2 arguments, and then 4 arguments. So let us just run this and see what happens. So when I called it with 4 arguments, 1, so here I got 1 plus 2 plus 3 plus 4, which is 10. This is 10. And here I got 1 plus 2, which is 3. Now inside the function, I have made a total. I've taken this total is a variable. This is a variable. Now, as I explained to you, this total variable will exist only in this part of the function. If you try to print total over here, it will be an error because it is outside the local scope. So these two print statements are in the global scope, whereas this total variable is in the local scope. That is why. So for x in arg, this is a loop. We have not done loops, but don't worry, we'll do it in the next chapter. Total is equal to total plus x. As I had remembered that this is, don't get confused. Total variable ke andar mein x add ho raha hai. X is being added because total is a box. So the contents of total are being added to x and again being put back to total. So if you think of this like a mathematical statement, you will think this is something wrong. But in programming, this is the way it is done. Total is a box which contains something, and x is added to the contents of total and then put back into the box total. So this is the advantage of this arg. So is it clear to everybody? Would somebody like to question on this, or shall we move ahead?
Sir.
Yeah.
So is this arg a keyword, or it's just a random word? Can we use a random word for this?
Yeah, you can use any. I use fox, you can use tiger, you can use donkey, you can use anything, but you should use arg. You should not use anything else, because that is the convention in Python, that whenever you are having a variable number of, whenever you're having a function call, whenever you're calling a function with variable number of arguments, you should use star arg over here. You should not use anything else, because if you use something else, then people will get confused. Because as I read, one of the zen of Python is code is more often read than written. One person writes the code, or maybe one team writes the code, but thousands of people read the code. Millions of people read the code. So if you write something else instead of R, you will be only confusing your readers. And code should be readable, right? Okay, shall we move ahead? Okay, so I think we can move ahead. So I'm sorry. Yeah. Okay. Now the next point is that one can combine a fixed number of arguments to a variable number of arguments also. For example, you can write a general purpose function which finds a square or cube or any other power of numbers applied to it, and then add these numbers to the result. So let the first parameter represent the power to which the functions are to be assigned, and the right. So suppose you want to write a function which finds the power to another. So you want to write a function like this: f power, then followed by the numbers. So what this would mean is, if I write f, suppose 2, 1, 2, 3, 4, I want this function to raise 1 to the power 2 plus 2 to the power 2 plus 3 to the power 2 plus 4 to the power 2. If I had written f 3, 1, 2, 3, 4, then I want the function to do 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 plus 4 to the power 3. So what is happening? The first number represents the power, and the rest of the numbers represent the numbers which are to be raised to that particular power. So I've written this function over here. Let me just copy it, and I will just show you how it runs. Okay, so let us run this. Let me just show you the function first. Okay, so I have written the function f with two variables. Variable 1, which is n, and the variable 2, which is star or asterisk arg. This n will contain the power to which I have to raise it, and this arg will contain the numbers to which the power has to be raised, right? So what I've done, let me just let us just, so again I've taken a local variable total, and for x in args, that means for every this, remember arg is a tuple, and when I write x in args, what Python's interpreter will do, it will take out one by one all the values of args tuple and put it in x. So what I'm doing, total is equal to total plus x to the power of n. So what is total is equal to total plus x to the power n, where n is the first argument and x is the one of the items in the args. I'm repeating, args is a tuple. Suppose this tuple had 1, 2, 3, 4, 1, 2, 3, 4. Then in each iteration of the loop, x will first become 1, then x will become 2, then x will become 3, and x will become 4. So here this loop will be executed 4 times because the tuple has got 4 items. If it had 10 items, this loop would be executed 10 times, and I'm returning the total So if I write print, instead of printing, I could have, suppose I write Z is equal to, and I write, say, W is equal to, then I will not get any output. Oh, I'm getting. But if I write print, this is because of what is called the standard out, and I don't want to go into the print. Let me write Z. I'm surprised to return total. It's giving none. Oh, no, it should be. So sorry. This should be like this. Now it's good. I made a mistake. I'm sorry. Now, and this is here also. Suppose I remove this. So now what is happening? Just let me show this to you. Now what is happening is Z will contain the return value of this. This return value of this function will go into Z in the first call, and the return value will go into W in the second call. That is why now when I run this, so let me run this. I'm getting only one output because I have printed the value of Z, but I have not printed the value of W. But suppose I was to write another print statement here. So I'm getting, so you can see that here the function output will go into Z, and the function, this output will go into W. All right. So I hope this is also clear. We can move ahead. If anybody has a question, ask. Otherwise, we'll move ahead. Yeah.
Yes, sir. If we comment the return statement, then what would be the output?
If you return the comment statement, okay, let's
Yeah.
do it. Yeah. Then output will be none.
Okay.
Output will be none. Because in Python, every function returns none if nothing else. This is the, so if you know a none has come, one thing you know, that the function is executed properly. So, when these comments and prints and commenting out, this is a great way of debugging your code, So once you start writing your own code and you start doing your own work and all, then these comments and all are very useful in finding out the thing, right? So shall we move ahead? Okay, I think we can go ahead. Okay, so the next topic is using ** quarg in a function definition to pass a keyworded variable length of arguments. Just listen to this statement very, very carefully. It's a very loaded statement. Using ** or asterisk quarg to pass a keyworded variable length of, so therefore, if you wanted to pass simply a list of parameters, you use arg. But if you want to pass keywords and their values both, then you will use quarg. So the format is used in the function definition and not in the function call. That means the quarg is, so this, if I have to first write the function, suppose it is fx, instead I will have to use double asterisk quarg. So in the function, this is the way I will write the function definition. So the keyword quarg, the word quarg will not be used in the function call, it will be used in the function definition. I am repeating the distinction between the function call and the function definition again and again, because many beginners they tend to get confused between the two. So we are dealing with two sides of the coin, the function call and the function. You can think of like this, there's a dhobi, and you're giving the clothes to the dhobi, right? So what the dhobi is doing here is your function definition. And when you're sending sending your clothes to Dhobi, that's a function call. So function, this quark will be used by the Dhobi. It will be used by the function definition. It will never be used by the person who's giving the clothes, the user. The person who's using the services of the Dhobi will not use quark in his call. But the Dhobi, where he's cleaning the clothes, there he will be using this double asterisk quark. I hope that is clear, makes sense. So you are passing a variable length of arguments during function call. You are passing the arguments as a pair of variable name and value. So quark differs from arg that in star arg, you are passing only the values of the arguments. You may pass one, when you do a function call, you will write 1, 2, 3, and that's it. And all these three will go into arg. But when you are using quark, when you're using double stall quark in the function definition, then in the function call, you will write f maybe x equal to 1, y equal to, sorry, not y equal to 2. Let me just clear this out and write it again. So if you're using a function call with quarks, you will call this function by writing maybe a is equal to 1. This a is a variable, b is equal to 2, c is equal to 3. And all these three values, these three keys and their values will go into a dictionary. They will go into a dictionary, and these A, the B, and the C, they will become the keys of the dictionary. And this 1, the 2, and the 3, they will become the values of that dictionary. So let us see this practically. Let us take an example. Let us do this. Let me run this code for you guys. Let me just show the code again. So this is again the function definition, and this is the function definition, and this is the function call. This is the definition of the function, and this is the function call. As I told you, you cannot call the function before the definition. So if you had put this line of code above here, it will throw an error. So let us see the function definition again. So now you see there's a very important difference between this line of code and the previous one, because it's a dictionary, and the dictionaries can only be accessed by their keys. They cannot be accessed by the index. So you have to write key k for, so the whatever you write k will take the key of the quarks dictionary, and whatever you write v will take the values of the quarks dictionary. And this method, this remember, quarks is a dictionary. Quarks is a dictionary, and dictionaries have a method called items. So let me, since we have not covered that in detail, let me just do it for you so that so that you people understand. Let us write. I think. You have to use a semicolon here. It's good. Oh no, wait. So see, I'm now let me run this. Yeah. Okay. So this is the dictionary. My dict is let me just show this. I'm going a little bit into dictionary, because so as I'd made the mistake, I'd put dictionary in the round brackets, but you have to use curly brackets for dictionaries, right? See, these are hints to the interpreter. The interpreter wants to be precise. It will not allow confusion. That is why if you write a round bracket, the interpreter gets confused. Now here it is. So if I just write, let me write K, comma V in my print K. Let me run this. There's some problem. My dict dot items. Yeah. See, I also tend to make a lot of mistakes. So just see this my dictionary for K in my dict dot item. So what this line of code is doing is it is picking up one by one these items. So there are two items. First item has a key of X with a value of 1. The second item has a key of Y with a value of 2. So this loop, this for loop, we'll cover loops next. It will pick out. So what is happening is, let me just draw this again. So the first item, this one, the X will go into K and the 1 will go into V. In the second case, the Y will go into K and the 2 will go into V. Now, you see, this is again convention. So whenever you use a dictionary, you should use K and V, but you could use something else. Let me write. I could use my key, and then I could write my value. And then inside this thing, my key, my value. So again, it is giving the sol. Now just see this. Here, what is happening? This my key is taking the items of this dictionary one by one, and the my value is taking the values corresponding to those keys one by one. So in the first iteration of this loop, my key takes the value of X. That is why you get X over here, and my value takes a value of 1. That is why you get a 1 over here. In the second iteration of this loop, this Y goes into my key and this 2 goes into my value. That is why you get a Y and a 2 over here. So I hope this is clear to everybody. If this is clear, then we can come to, is it clear? Should we move ahead?
So one question.
Yeah.
So can't we directly pass a dictionary without using the double asterisk on the function definition?
No, you can't. You can pass a dictionary. Of course, you can pass a dictionary.
So then what is the point of double asterisk? Like we can directly do it, right?
You can do it, yeah.
Then,
you can pass a dictionary. I'll show you. Let me write. Suppose you have this thing, and suppose you write. You can write. A function. Right. Let's write def. You could write def my func. Let's call it d1 print d1, right? And let's call this function. Let's comment out this part. Let us remove it. Let us print my func. No, let's not use print. Let's just call it. Let's call my func with my dict. What should be the output? Let's see. Let me just show you. So what I've done over here, the question was that can you pass a dictionary? Of course you can pass. So this dictionary has been passed over here. So my dict has now, when I call, this is the function call. This is the function definition. And again, to just repeat this, my dict is in global scope. This thing is in local scope. And this again is in global scope. So I have called the function with my dict. My dict happens to be this. So this my dict is x1, x colon 1 comma, this goes into d1. And when I ask them to print d1, it prints this whole thing. So you can pass a dictionary like that. But then
Sir,
every time you want to change the number of items in the dictionary, you'll have to construct a dictionary in the code and then you have to send it. Right?
yeah, yes, about it. Yeah.
I mean, there can be more ways of doing the same thing, you know. But the Zen of Python, let me just show you the Zen of Python first. This is the Zen of Python. Let me just show you. If you just print this statement, import this will give you what is called the Zen of Python. Beautiful is better than ugly, explicit is better than implicit. These are very, very, they have a lot of meaning in them. So just read them very, very carefully. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Very, very important. That's why we always use star arg. And we don't use things like star fox or star cat or star. We don't use this. This is bad. This is good. Similarly, we use star quarg. We don't use star quargs or with capital K. We can do it, but we don't do all that thing. So special cases. So this is what the Zen of Python is. Let me just remove this. We have got digressed from our main topic, right? Let me remove this also. Let me just delete this. This is from edit. Let me delete also. All right. So let us just see this code. Okay, this is a very important piece of code, which okay. So what is happening? I've called a function. I've defined a function def, and I've used the thing quargs. And for k and v in quargs.items, print value of value is this. Value of something is this. So to print value of k is v. So now this is the function definition. Again, I'm repeating, this is the function definition. This is the function call. So I'm calling it with lion equal to roar and bird equal to chirp. So when I do this, the quark will contain two items and two keys and two values. It will contain the key of lion with the value of roar. It will contain the key of bird with the value of chirp. So what is happening is it will print, as you can see, these two lines of these two lines have got printed from that particular line of code. Now, here I have created a dictionary which contains 1, 2, 3, 4. 4 keys and 4 values. Meow, bark. Sorry, 3 keys and 3 values. And horse ka neigh. So there are 3 animals, cat, dog, and horse. These are the 3 keys. And the sound, 4 keys. Cat, dog, so 3 keys, and horse. And there are 3 values, meow, bark, and neigh, which are the 3 sounds made by the cat, dog, and the horse, respectively. So when I do this, I get this kind of an output. Value of cat is meow, value of dog is bark, value of horse is neigh. In fact, you can, for those who have doubts, we can just write let's write a print. Let's write a print quarks. Let us write quarks Let us run this. So you can see, this is disturbing. So you can see that quarks is being printed in this line of code. And it is a proper dictionary with two items, lion and a bird. The lion is a roar and the bird is a chirp. This output is coming from this function call. In the second function call, this one, it is giving a quarks of three items: cat, dog, and horse, which are the three keys with the values of meow, bark, and neigh. Is it clear to everybody? Shall we move ahead? Yeah. Anyone with any questions? So, okay.
Yes, sir, we can.
Okay, so just this script I had written here, this function, it was mentioned that arg acts like a tuple and quark acts like a dictionary. You can see this here. I've created an arg and the print arg is arg. It is printing. I'm calling this function, first function I'm calling with 1, 2, 3. It is printing arg is 1, 2, 3. The second function I'm calling with three keys and values, and it is printing the dictionary. So this is, I hope, clear. So we can skip the, okay. I was told by Mr. Balaji that recursion should be covered. So would you like me to do recursion, even though it is hardcore computer science, it is not really connected to your line of, as I understand, all of you are budding hackers and this thing, but let's go into recursion, okay. So I am done with the functions basic types. That means I've covered functions, the definition of a function and the call of a function. And let me just repeat it. One sec. There are certain other parts of the things which I will not be covering here. Just page number 92. Just one sec.
I think there is some mismatch in your flow and the flow which is coming from Code Tantra. So some of the exams questions which you were presented, which we attempted yesterday, has already covered some of these concepts. So I think you can.
Okay, yeah, I'm not aware of the other. Somebody else is taking Python along with me. I'm not really aware.
No. It is a courseware which is prescribed along. So you are doing one part. Parallelly, we are supposed to follow Code Tantra. So Code Tantra, there's some overlap in terms of the questions asked. So we went through all this recursion yesterday.
So okay, then I can skip recursion.
I think so. If everybody agrees.
No, sir.
No, sir. Please explain recursion.
No, sir. Please explain.
Even this variable names underscore name and is equal to underscore main also.
Yeah. Okay. You want me to cover that? I thought that you can do on your own, but okay. Let me just okay. Actually, this is not about functions, but this is about Python in general. So let me just go through this. How the Python interpreter searches for modules. Modules we have already discussed. But this is how Python interpreter searches for modules. When the interpreter comes across an import statement, it looks for it on the host user computer. The Python interpreter searches the modules in the following sequence. Let me draw the sequence. So this is the first part. So let me just tell you that Python, whenever the interpreter comes across an import, suppose it is import, say OS here or something, this is a module, right? This is a module. Now, when Python sees this, it has to find this module. So how does it look for it? The first is it looks for the module in the current directory. So if the module is found in the current directory, you can get the. If you want to know the current working directory, use the get CWD function on the OS module. Let me just show you. Just let me. os.get. Let's run this on our this thing. So this is actually we are going away from our main listing, but I think it's important. So let me just insert a cell above. Let me copy and paste. os.get CWD. Yeah. So this is my current working directory. That means the program I'm running is running in the directory C. You know, there's a confusion of single slash, double slash, forward slash, backslash. Some operating systems you will have, like I think in Linux it is forward slash. So it will be C users Anurag Gupta in maybe Linux, but I'm on a Windows machine, so it is a backslash, and the double backslash is basically for an escape character. I don't want to go into that right now. We'll cover that in our chapter on regular expressions if we come over there. So basically that is the idea. Let me move ahead. So first is it will search for in this thing, right? Suppose it finds. Then suppose it doesn't find, then what it will do, it will go for modules which are given in sys.path attribute of the system module. So let us run this. Let us run this. Oh. Why is it giving? Sys.path. And there's a problem here. Okay, I think it will run on the. Okay. I've understood the okay. I've understood why it's not working. Let me just do it. Yeah. I'll just explain what went wrong, and mistakes are a great way of learning. You see, I imported a module called sys. Now, in a module, you can have attributes and you can have functions. Let me explain that sys module, it contains certain variables which are called attributes, and it contains certain functions which are the functions. So the mistake I was making over here, which is a learning point for you and me and everybody, I was using the path. I was using sys.path. This I was using like this. So what the Python interpreter was thinking, or what it was understanding, was that path is some function which is contained inside the sys module. But path is not a function, it is an attribute. And this is what it contains. Just let me just show this again to you. This is what it contains. It is a list. The sys.path is a list. I can show it to you. I will show it to you. It contains this is the first item. Then it contains with a comma over here. Then second item. Then third item. Like that, it contains so many items. So therefore, if the Python interpreter does not find a particular module in the current working directory, then it will look for the sys.path variable, which contains a list of all the other directories where the Python interpreter is supposed to search. And I can show you that sys.path is actually a list. I can show you. I can do type. And I get a list. You can see this. So you can see that that sys.path. So what is path? Path is a variable inside the sys module, and that variable is of the type list, and the list contains the list of all the directories which the Python interpreter will search if it is not able to find the particular module which you are trying to import in the current directory. Does that make sense to everyone? Shall we move ahead? Yeah? Anyone? Okay. So I think that is understood. Now you see, whenever you write, since we are using the Jupyter notebooks, so many times we miss out on the on the way Python is written or the programs written. You should actually be right. There are many ways of writing this thing. Some of the most common interpreters are, one is called VS Code, other is called Spider, SPYDER. I will show you. And then there is some built-in, this what is called for writing and running Java programs. Python program. We are using Jupyter notebooks, but we can use VS Code also. We can use Spider also. I'll just show you Spider on my. I will show you both. This is your. But we are getting digressed from the main topic anyway. So this is your VS Code. Note it is VS Visual Studio Code, not Visual Studio. So you can use Visual Studio. It's an excellent IDE, which is called Integrated Development Environment. There are some popular IDEs for Python are Visual Studio Code and PyCharm. There's another one called PyCharm, and there is Visual Studio Code. PyCharm, unfortunately, is a paid, you have to pay for it. It is not open source, it is not free. But Visual Studio Code, VSC, is open source and free. And I only work in open source software. I never like to work in something which is proprietary, something which is paid for. I like to work in open source. And Visual Studio Code is an excellent add-on called Copilot. I will not go into this, but this you can actually write. This Copilot can actually write codes for you. So if those who are interested can do their own research. I don't think we have the time, and this is not our this thing. But coming back to the topic main. Now, why I gave all this background is that whenever you are writing a program in Python, you will have to save it as something.py. Something.py, right? Now, when that .py file is run, it can be run in two ways. It can be imported or it can be run as a module. That means, suppose you write up a library and you want certain functions of that library to be run in your program. That means you don't want the library to run on its own, but you only want it to be imported, right? So if you write this statement, underscore name underscore equal to main. If this is true, then it will run as the main program. But if it is false, it will be running as an import, right? Now in Python, this double underscore followed by something, then by something is a very common technique, very common practice in Python. These are called underscore. This is called double under methods or dunder methods, dunder. So whenever you see, like for example, we'll be doing many of these. So if this is not clear to you right now, don't worry too much about it. I'll come back to this this thing. Let us go to recursion. Okay.
sir.
So I think we can, maybe it's not very clear to you. It will become clear. Well, don't worry, it's not very difficult at all. Yeah. We have done this, called by value, called by this thing. Just 1 sec, let me come on. Just I'll just show you this. I've written this. I hope this is. Let me just make it bigger. So if you write this program, if you write these lines, and if the program is being run, then this will be run. If it is imported, then this will happen, right? For example, I have written this thing. Let's not go into this. We'll cover it later on. Let's come to recursion. Let us come to recursion, then we can come on this. Suppose a function calls itself repeatedly, and each call, it breaks the problem into simpler cases. Such a function is called a recursive function. So a function can call itself. Suppose it's like this, that you have to find, say, 5 to the power of, say, 3. So this could be 5 to the power 3 can be 5 into 5 to the power 2, which can then be 5 into 5 to the power into 5 into 5 to the power 1. So what is happening? We are breaking down this problem into smaller problem. So what we are doing, we are converting 5 to the power 3 into a multiplication of 5 with a 5 to the power 2. And then we are doing multiplication of 5 into another 5, and then 5 like that. So this becomes clear. Okay. So for a function to work recursively, you need two things. For any function, in computer science, if you want a function to work recursively, it has to have two things. First is, in each iteration, each call, the problem becomes smaller. That means, like I gave the example 5 to the power 3. So this got converted into problem of 5 to the power 2. So this is a smaller problem than this. So it must happen. And finally, there must be a base case, which would be 5 to the power 0, which is 1. So there has to be there are two things which are required. Number one, the problem has to become smaller. And number two, there has to be a base case. The base case will then terminate the recursive call. Otherwise, the function will keep on calling itself endlessly. So there is a break, there's a base case at which the function terminates and the recursive call will reverse. This is the base case. A base case occurs when the problem gets solved without further recursion or without any further call to the function. It is the base case which ends the recursion. Without the base case, the script would go into an unending infinite loop. So we will understand this with example, but I hope this is understood. So let us see. So what are the three characteristics of a recursive algorithm? It has three characteristics. First, a recursive algorithm must call itself recursively. Very obvious. So if you're trying to find 5 to the power 3, then that you suppose you're writing f it's a number. Then this within this function, call this, we'll call f again. It will become clear. A recursive algorithm must have a base case. I've already explained. A base case occurs when the problem after repeated calls to the recursive function becomes so small that it can be solved directly. A recursive after each call to recursive function must move towards the base case. So well-designed recursive algorithm, after each iteration, the problem must become smaller than the original problem. So this we'll understand. Let us, I've written some pseudocode. So a typical recursive function is written like this: def recursive function, then the attributes which you pass, followed by the colon. Then if loop generally contains the base case, this contains the base case, or rather the terminating case when the problem does not need to be divided any further, and else is the recursive solution. So this will become clear. This I've written some pseudocode just for you to understand, right? And how this thing works. Let me just using recursion to find the factorial of a number. As you all know, 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which could be treated as 5 into 4 factorial, which could be treated as 5 into 4 into 3 factorial, and so on. And finally, 5 into 4 into 3 into 2 into 1 into 0 factorial. 0 factorial is the base case, and 0 factorial, as we all know, is not 0, but it is 1. Let's see this again. So this is the base case. Fact n is the function. The base case is 1 if n is equal to 0. And it is n into fact n minus 1. So whenever I call, if I have a function fact n, then somewhere inside the function, I am calling n into fact n minus 1. So this is again calling it, then again calling it, then again calling it till the base case is reached, and then the whole process reverses. We will see this, and I think since you have covered, I'm told that you have covered iteration, so maybe you already know these things, so maybe we are just repeating, but let me just go it. No, let's not do this. Okay. So there are two ways, recursion versus, there are two techniques, recursion technique and iteration technique. Recursion is not a problem to all solutions. It is a problem, it is a solution to only, sorry, it's not a solution to all problems. It is a solution to only certain types of problems where the algorithm, where the problem is becoming smaller. Advantages. Many recursive algorithms are very elegant and hence produce clean code. Recursion can often break down a complex task into sub-problems. Many sequences are easier to generate via recursion than via iteration. In fact, there's a typical problem. I've written the code of that in my book, which is called the Tower of Hanoi or Tower of Hanoi. The Tower of Hanoi problem is very easy to solve by recursion, but very, very difficult to solve by iteration. So I'll just show you the problem also. These are the disadvantages. Let us go into the, okay, Tower of Hanoi. Let us see this. Oh, this page has gone out. So I'm sorry. I'm taking it to the wrong this thing. Let me open my book and I will come there. Okay. So I have written again factorial, 5 factorial can be written as 5 into, this is the visible to all of you. Let me just again make it a bit bigger. So 5 factorial is written as 5 into 4 into 3 into, and if you reverse this thing, then it becomes 5. See, reversing the parentheses from this side to this side, it makes you see the problem in a better way. You are able to see 5. This is basically 5 into 4 factorial, like this. This is 4 factorial, which goes into 5 into, this is 4 into, so it's just like this, so you can do it. So let me just so what has happened is that n factorial is equal to n into n minus 1 factorial, which is equal to n into n minus 1 into n minus 2 factorial, like that. So on. I've written this thing over here, so I think let us run this code. It should be there on the right. Let us run this code. I'll go over it line by line so that you guys understand the whole thing. What's the problem? Okay. Okay. So this code has a number of, I'll go through this code line by line so that you guys can understand. As mentioned, I like to mention again and again, this is the function definition. And this is the function call. It's a bit complicated, and there is a line of code called input this thing. Now, I didn't mention this to you. Let me just show this to you. No, suppose I write. Suppose I write. Like that my number is equal to okay. So let me first show you the code. Then, so this is a very important function, built-in function in Python called input. So whenever you write input followed by something within quotes and another this thing, then the script will ask you to give an input. Let me just show it to you. Let me run this. Let me just run this. Oh, sorry. See, I keep on making these mistakes. God, what is wrong? I have again made some mistake. Let me just collect it out. Just give me a second. Okay. So sorry. Yes. I'm not supposed to give anything over here. Yeah. See, I made a mistake. Input, give me a number. So I've given this. This will get printed, and the interpreter is asking me to give me something. And then, the line of execution has halted over here. This print statement has not been done. The moment I enter something, it will be printed. Let me write 4. Let me write 4 here. Let me write 4 and let me run this. So this I had not explained to you. So input is the function and this is simply a hint. I don't have to give it. And what will happen, whatever I print will go into my number and that will be printed over here, right? Now let me just run this, let me remove this. Now let me run it again. So now that statement, give me a number, is there come, simply it has come 3, I print, it prints 3. So I hope, but there's a very interesting thing. Let me show you. Let us print type my number. Can someone tell me what will be the type? Anyone?
Integer.
String.
Integer.
Let's see. String. So this is the difference between Python 2 and Python 3. In Python 3, which we all use, Python 2 nobody uses anymore. Whatever is input is always presumed to be a string. Now, if you want this number to be a int, then you have to specifically typecast it. You have to write. Let me write int my number. Now let me print. Let me write 3. Print, oh sorry. Oh, yeah, sorry. You have to, I'll explain why this happened. Right, X. Yeah. Right. So you see, I made a mistake again, but mistakes are always a way to learn. Now, strings in Python are immutable. That means you cannot change the type of the string in place, but you can change the type and give it to another variable. So what I was doing earlier, I was doing my string, my number, or rather my number is equal to int my number. So I am changing the type of int from type of my number from string to int. I cannot do it. It will not work because a string in Python is immutable object. Somebody asked this question in I think 1 or 2 classes back about immutability and all that. We'll go into that part later on, but that is why it didn't work, right? So let's come back to the.
So
Yeah.
instead of this, we can write int function under the print statement.
Come again?
Instead of writing int, we can use print statement along with print statement.
Yeah, yes. You can use print int.
Yeah.
You can do it because you're not changing this. Whatever conversion is happening, that is coming out on the standard output, std out, which happens to be your screen. Fine, that's okay. You can print it, you can give it to somebody else. You can give that output to X, but you cannot change the type of my number. I hope that is because it's a string and it is immutable. Yeah, hope that is clear. I think this is a distraction. We don't want to go into this, right? So let us delete this cell and let's come back to our mistake, right? Let us understand this code. So again, From here to here is my function. It's a recursive function. If number is equal to 1, return 1. This is a base case. I'm surprised. I thought it's 0, but here's 1, right? And print number. I'm printing here. This print statement is redundant. We can skip it also. The important thing is number into factor recurs number minus 1. So from here, again, this function is being called. And if this number minus 1, if it has become 1, it will terminate. But if it is say 2, then this part will be skipped, and again this will become, and then again it will be called, right? By 2 minus 1, which is 1. So if we start with say number, if number is equal to 3, in the first call this will be skipped. This will be called with 3 minus 2, 3 minus 1, which is 2. Again will be called with 2. Again this will be skipped. Then again this will be called with 2 minus 1, 1, and it will terminate. Is that understood by everybody? If that is understood, then we can move ahead. Otherwise, we can. Right? Now, you might say that see now just see this line of code. Input number is equal to int input enter a number. Now note one thing. If I don't enter a number, suppose I enter a string over here, then the Python interpreter will not be able to convert that string into an int. It will throw an error. Let me just show this to you. So let us run this. Let me say X. See now the error. Let's see the type of error is very useful. It says invalid literal for int with the base 10x. So if you want to write a program where the user is a funny character, most users are if you have 100 good users, you will always have 1 or 2 bad users. Somebody will print an X which will throw an error. So you should be able to handle that error. And how we handle that error, we cannot discuss right now. But again, let us run this. I want to show you. Enter a number, say 4, and we get 4. So enter a number. Let me just show the output. So let me just discuss this. We entered a number 4, right? So remember, this is the function definition. So this script will start from here, not from here. Just remember, because this is the definition. The definition is not executable code. This will not be executed until this function is called. So the script will be called from here. Input number, enter a number. This got printed over here. I put a 4. It went into input number. So now input number is 4. This is again a error check. Somebody might put a -3 or a -4. Then this will not be printed. So if input number is greater than 1, which here it is, print the factorial of input number is factor recursion, which is our function, with the number of 4. I'm calling it with a 4 here. So let us see this. When it calls with a 4, this will not be executed because the number is 4, not 1. So this if will be skipped. Then number into factor recursion, number 4 minus 1, 3. So again, the function is called with the value of number equal to 3. Again, this is skipped. Again, this is called with a value of 2. And again, this is skipped because it is 2. And finally, it becomes 1. And then this happens, return with a 1, the function terminates. Has everybody understood this? I'll just show, if you see it in a diagram, it's very, in my book, I've made a diagram. Let me just show you. Yeah. So see, this is a factorial of 5 recursively. So I'm calling with frec 5 and return 5 into frec 4. So it is called here return with frec 3. This goes here. Then return with frec with 2. It goes here. Then with 1 goes here, terminates 1, then 2, then 3, then 6, 24, and finally 120. So this is how the function So just to cap it up, to recap it, we need to understand that when that means when this return statement is returned, it will not be returned. Rather, it will be again called, and then again called, and then again called, like the 5 times. If it is five times, 4 times it is called, 5th time this happens, and then it starts reversing, returning this, returning that, returning this, like that. I will become clear to you once we do another example. So that is clear, I hope, to all of you. So shall we do one more example of recursion, or should we move ahead to the next topic? Somebody would like to tell me?
Sir, one more example.
Yeah, okay. So in my book, there are a number of examples. This is a very complicated algorithm. I don't know. Let's not leave it. Okay, let us do this. Finding the recursion to find a to the power b. This I've already explained to you. To find a to the power b, this is equal to a into a to the power b minus 1, which is equal to a into a into a to the power b minus 2, like that. So let us do this program. Right. Yeah. Recursive function to find a to the power b. This is the code which is there in the HTML on my GitHub page. You can just download it. The advantage is you can just copy and paste, it will run, right? Example of a function. This example with the starts with a hash, which is a comment. A to power b in the program would be written as a double asterisk b, right? So I am writing this function. The function which I am using is called xf. And I had explained to you this is a typical case of camel case. But now I'm told that you should not name functions like this. You should call them rather xf or whatever you want to write. Because this is the snake case, you should use snake case and not use camel case, but depends. It depends, right? So it's your choice. Let's come over this function. Now, if e is equal to 0, right? If e is equal to 0, that means b to power e, if e is equal to 0, so that means b to power 0, which is basically 1. So this terminates, right? So this is the base case. When the exponent becomes 0, that is the base case, right? Now just to repeat, this b is the base and e is the exponent. So the base case is e equal to 0. Now note that it is not e equal to 0, it is e double equal to 0. Let me just it's become dirty. So it is e, that means we are comparing the variable e to 0. This is not what is happening. We are not putting a 0 inside the e. We are comparing the two, right? And this is called a Boolean context. So whenever you have an if statement, then whatever is following the if statement has to generate a bool value. So when you're comparing e double equal to 0, when you're doing e double equal to 0, this whole thing will either generate a true or a false. A true or a false or a false. So here, this is the base case, else print exponent is e. This is just, these print statements are just to make the code easier for you to understand. Temp r is b, which is the base, into xb into e minus 1. So I put print for x, this thing, result temp r. So I'm printing, you don't have to write these. I will comment them out, it will work fine. Return temp r, right? So where is the recursive call happening? It is not happening in the return like in the previous case. It is happening here. Let me just show it again to you. The recursive call is happening here. This is the recursive call because let me write it. I've written temp R is equal to B into XPF, which is my function, B comma E minus 1. So I have decreased the problem by one number. If E was 5, now it is becoming 4. So I'm calling this function with a 4. Then I will call with the 3, then I will call with the 2, then I will call with the 1, and finally when I call with the 0, then it will this return will happen. Right? And then all of these will happen in reverse. You can just show this to you. No, let me just let us run this code. Let us run this code. Enter the base number. So here, just let me just show you. There are, see this, I told you this is the function definition. My first line of code which is being executed is this. Enter the base number, then enter the exponent. So let us enter the base number. Let us take the base to be 5. Now it is asking enter the exponent. Let us take the exponent to be 4. So 5 to, so basically what we are doing 5 to the power of 4, which is equal to 5 into 5 to the power 3, then 5 into 5 into 5 to the power 2, like that, ultimately 5 into like that, and 5 to the power 0. So let us run this. Yeah, the output is important. Exponent is, so these lines are getting printed one by one, 4, 3, 2, 1 for so terminating. So I've written here. Yeah, देखो ये print statement है. Just let me just exponent. This line of code will be printed only when this part of the code is entered. I have put it here just for you easier understanding. So I'm seeing that what I'm seeing that 5 say E becomes 4, then wait. From 5 it has become 4, then 3, then 2, then 1, and when it becomes 1, and then 1 के बाद 0, then 0, so terminating. Exponent 0 हुआ, terminate हो गया, और जब फिर reverse होगा, exponent 1 result is 5, because I'm printing this thing, I'm printing the results. Then 5, then 25, then 125, and finally 625. So is it clear to everybody? Yeah. Is it clear? I'd like to stop for a second and then we can move to the next problem. Anyone would like to react to what I've said so far? Does it make sense? Is it logical? If you have any questions, you can ask me. Ask me anything on recursion. You can ask me anything on recursion. I will try to answer. Anyone? Let somebody say a hi at least so that I know you all can hear me.
Yes, sir.
Okay, so I presume that this is clear. So while we are at recursion, we may look into another function called, this is called for finding GCD. GCD is called the greatest common divisor. So this is one of the oldest algorithms in the world. As you know, in high school mathematics, suppose you want to find the greatest common divisor means, suppose you have two numbers x and y. You need to find the biggest number which can divide both x and y. Right? So obviously, if x is smaller than y, then if they're co-prime, That means there are no common factors. Then this will be, then the GCD will be a, if X and Y are co-prime, then GCD will be a what? Can someone answer? Suppose you have 2 and 3. So 2 and 3 are co-prime. That means there is no common factor between 2 and 3. So what will be the GCD?
1.
Yes, 1. So if two numbers are because the prime numbers are very important especially in cryptography and even in data science. So and many of the algorithms and because cryptography algorithms run on prime numbers, basically large prime numbers. So if they are co-prime, then the GCD is 1. I have written a script over here. Let me just copy it and run it for you guys. So let us this. Let me just show you the function. So R GCD AB print recursive GCD function with A, B. This is a bit confusing, but you know, to find the co-prime number, let us say we have to find the co-prime numbers of say 6 and say let us call it 6 and 8. So what do we do? The way we do it in high school mathematics is we take the smaller number and we divide the bigger number with the smaller number. That means 8 we divide by 6. 6 ones are 6. We get a remainder of 2. Then we divide the 6 with the 2. It is 3. 3 is 6. So 2 is the GCD of 6 and 8. This is the way it is done in high school mathematics. If you maybe in class 7th or 8th, somewhere around that time, this particular algorithm is introduced to kids in schools, that how to find the GCD, and this code is there. I think I'll leave it. You can study the code on your own, right? Because it's a bit tedious to go over this whole thing. Then there is a very interesting, very popular series in computer science, which is called Fibonacci numbers. And this is Fn is equal to Fn minus 1 plus Fn minus 2. So you can start with the seed of F0 equal to 0, F1 equal to 1. You could start with some other seed also. So this I will also skip. I think this is then yeah, let's come to this problem. Tower of Hanoi. Okay. Let me just what is Tower of Hanoi? Basically, there are 3 spokes. On the first spoke, there are certain discs. Here I put 4 discs. And the rule of the game is that and now the problem is that you have to move these discs to another spoke. The rule of the game is that in the initial problem, there cannot be a bigger disc on a smaller disc. That means if this is 1, this is 2, this is 3, this is 4, then the diameter of 1 must be bigger than diameter of 2, which must be bigger than diameter of 3, which must be bigger than diameter of 4. So this is the initial position. And when you shift, you cannot put a bigger disk on a smaller disk. That means you cannot have 4 here, and you cannot put a 3 on top of this. Let me just draw it again. So if you have again 4, 3, 2, 1, and then this and this, so you can put the 1 over here. Then you have to put the 2 over here. This is 1, this is 2. And now in the next move, you have to put this 1 on top of the 2. Then you can put the 3 over here. Then you have to put the 1 over here, then 2 over here, then 1 back onto this. So once you do that, you'll have 4 over here, and you'll have a 3, 2, and a 1 over here. So this is the tower of Hanoi or tower of Hanoi, this thing. So let me just um, again if Mn represents the number of moves, then it can be written as 2 into M n minus 1 plus 1. Let me explain this equation to you. Suppose you have a tower of Hanoi with 4, 1, 2, 3, 4. Let me call it 1, 2, 3, 4. This is, and there are spoke 1 and spoke 2. Suppose you want to shift this entire thing over to this one, right? This is equal to moving these 3 over here. That means after this thing will happen, you'll have 4 left only over here. And on spoke 2, you'll have 3, 2, 1. And then you will move the 4th over here. And then you will again move these 3 to here. So M4, or rather capital M4. So let me just, so capital M4 means you are moving these 3 twice. First on spoke 2, then shifting the 4th over here, then again these 3 on top. That means you are shifting M3 twice, and you're also making an additional move of moving the 4th to the 3rd spoke. So that is how this equation has come. So that is how this equation has come. Mn is equal to 2 times Mn minus 1 plus, let me just repeat this again. Maybe everybody has not understood. Let me take a blank sheet so that it becomes easier for everybody to understand. Yeah. So let me just draw it more carefully. Suppose it was 4, 3, 2, 1. This is spoke number 1. This is spoke number 2. This is spoke number 3. So we are required to move these 4 into spoke number 4. We have to move them here. So this could be treated as, in this is stage 1. Stage 2, I have only 4 over here. And somehow I have moved the top 3 to this one. So 3, 2, 1. So we have 3, 2, 1. And this spoke is empty. So now I move this 4 in the 3rd stage. This is stage number 1. This is stage number 2. In stage number 3, I make this spoke empty. And I move this 4 to here. This is 4. And then I shift these 3 again on top of this. So shifting 3, let me call it M3. So can I write then M4? M4 is equal to 2 times of shifting of 3, M3, plus shifting of the 4th, this. So I've got Mn is equal to 2 times Mn minus 1 plus 1. So, you know, the root of programming is to understand the logic of the algorithm. So once you understand the logic of the algorithm, then it becomes quite easy to convert it into code. So is this algorithm clear to everybody? Then only I'll move ahead. Yeah. Anybody has any question on the algorithm?
So what is the purpose behind of this cycle?
What is the, no, we are, the tower of Hanoi is a very typical problem in computer science, which if any one of you are students of computer science in a typical engineering college, this is one of the problems which is to be solved, and it can only be, generally it can only be solved by recursion. So what I've done, so so what I've done is I've converted this problem of shifting n disks into a smaller problem of shifting n minus 1 disks. So therefore, if I use this equation, then I can use recursion to solve my problem. Now you come with the, I could not really understand your question. Can you repeat your question, please?
Sir, what is the purpose behind it, and where we can use this equation, this type of like cycle? We are shifting from one scope to another scope?
No. You see, I cannot tell you where it will be used practically. I'm not aware, but just I'm showing you an example of it could be used somewhere. Maybe you have a real life problem where you are required to shift something to another shift in a computer science problem. I can't tell you the answer to that. But I can tell you that this is an algorithm which can be broken down from a bigger problem to a smaller problem, because mn has been converted into a problem of mn minus 1. And there is a base case, right?
Okay, sir.
So let me show you the code. This is very okay. So I have this function I've written on my own. So I don't know. You can read in the HTML. Try to figure it out. So count equal to 0. Now there's a new, and this is the function from here to here. This is the function, and this n equal to 5, and then list range 0 n0 minus 1. Move. ऐसा करते हैं इस पर्टिकुलर कोड को पहले आप लोग खुद से स्टडी करो एक बार. इनफैक्ट द बेटर वे वुड बी डोंट रीड माय कोड, try to write the recursive function for tower of Hanoi on your own. And
Okay, sir.
the internet is full of example codes. So if you do a simple search on Python tower of Hanoi or tower of Hanoi code, I'm sure you will be able to find many examples. But I just want to show you in my case, the interesting thing is that there are 3 lists. They're moving around. I just show you. So I've done the printouts which show that here this is the first spoke. The spokes are represent one spoke, second spoke, third spoke. 3 डंडे. पहले उसमें जो सबसे छोटा डिस्क है एक वो चला गया डंडा नंबर 3 पे, तो डंडा नंबर 1 पे बचता है 5 4 3 2. डंडा नंबर 2 is empty, right?
Okay, sir.
Then 2 goes to danda number 2, 1 remains, but these dandas have been chained, right? Then 1 goes on top of 2 and this becomes empty. Then 3 goes in the list number 3 and this becomes 5 4. Then 1 goes on top of 3. 1 goes on top of 4 here. This one goes here, which is will come here, and 3 and 2 are empty. Then 2 goes on top of 3 here. This becomes empty. So like that, every step is printed out. You can.
There is an interesting page at Wikipedia, Tower of Hanoi. It gives the animation and a lot of applications for people who are interested.
Yeah. It's good advice by someone. May I know your name, please, sir?
Sir, I am Anand Shankar.
Anand Shankar. So Mr. Anand Shankar is mentioning that there is a Wikipedia page on the Tower of Hanoi, so which has some animation. So those who are interested in following this, there are some people who want to understand every minute detail. So those who are interested can go into this. Should we stop here, because I think we have covered quite a bit. We have been at it almost for 2 hours now, right?
Okay, sir.
So I
Yes,
wanted to start with the classes and all, but not classes, with flow control. So it will be, I think, one better way we can move faster if you guys also go over this thing. So I'm planning to cover this chapter number 6 in my next class, which is basically on flow control. So आप लोग क्या करना, आप मेरे GitHub page पे जा करके download this chapter number 6. I'm again repeating. I'll just show you again. So just one sec. So let me just this is my GitHub page. So if you for those who are new, let me repeat it again. So you go to Google. Those who don't know anything about GitHub, go to Google, write GitHub AG 999 Git. This much you can remember. Just enter, and this is my GitHub page. You come here. So now there are how many? There are 6 repositories. This is, just let me show you. These are the 6 repositories. 1, 2, 3, 4, 5, and 6. So just go over this, just click this repository. Right? It is coming here. So now again, you can see there are 3 folders, 1, 2, and 3. These are the chapters which are not there in the print format. The 5 chapters which are you can download. PPT notes as PDFs. These are the PPTs which I'm showing you, but they're in the form of PDF. Book chapters STF. This is the one of concern. Here, all the 20 chapters, their HTMLs are available. So you go to this book chapter HTML. And now you go to chapter number 6, flow control. No, sorry. Don't go there. Sorry, book chapters, you do this and come down and click on this. Just right click, open a new tab. This thing, right? This is chapter number 6. This is what I'll be covering in my next class. If, elif, else statements, then if else statements, then omitting the if clause without the else, that is if without an else, then nested if else, then avoiding nested ifs, which is having too many nested if is a bad programming technique. How to avoid it? Then I'll talk about the while loop. Then I will talk about this break, continue, and pass statements. And then while with else. So these are the things which I will be covering in my next class. And then infinite loop, obviously, right? Or these are the things I'll be covering. So if you are able to do this, then I would like to switch straight away to chapter number. After this, I would like to do classes first. So I will then go to, just one sec, I'm telling you. I'll go straight to chapter number 13. So after that, if you can do this, then you come straight to chapter number 13 and open in a new tab. This is chapter 13. This is concept of operator overloading, which I discussed a little bit. I'll do it again. Then short note of function overloading. Then this you can read. This is it's very, very instructive. You don't have to buy any book. I'm sure that if you are able to just go over there, then creating a simple class and simple objects, this is very, very important, because if you don't understand classes and objects, then you really cannot do anything in modern day programming with any language. The concepts are the same whether you use Java, C++, Python, or any other. Aajkal nayi languages, Go and all, Golang and all have come. I don't know. So this you can do. Then OOP concepts specific to Python. There are certain specific concepts. A class with the init method. This we can cover. Then class which has attributes, and then so these are the topics. So I would like to cover. So to repeat, I would like to cover chapter 6 and chapter 13 in my next class. So if anybody has any comment, questions, observation, suggestion, do it now. Otherwise, we'll stop for today. Anyone?
No, sir. Thank you.
Okay. So, okay. Good day to all of you.